All right, welcome class today. We have lab going on, and as you'll see, you have 4 different colors of solutions, and you have a little dump cup with straws for your group. Your group will also need a sponge to clean up any messes that you make. And remember, any mess you make is your mess. Mr. Smith does not clean up your mess, and so I will clean up my messes. And so I'll be circulating around. Here's your goal. I need you to get all 4 colors in this straw stacked, no foreign objects in the straw, and no air gaps between them. Go. That's it.
Okay.
I'll walk away at that point. Now, when students start doing this, what will happen is, as they start getting, they'll want you to come to them, but I never do. I intentionally go away. Here, we'll just do these 2 colors really fast. They might have this, like, Mr. Smith, Mr. Smith. Of course, then I'll throw another sponge at them, tell them not to get stuff on the floor. And I'll be like, I'm too old. I cannot see that far away. You'll have to come to me. Because what they'll do is they'll go like this and start coming to them. And, of course, it's starting to mix.
Yes.
Because they've changed where the bottom is. The bottom has changed. It's now here, not here. And so it's mixed. But if they simply would have kept it, switch colors, if they would have simply kept it this way, then it wouldn't have changed. Since we know what's going on with the blue being less dense. And so as soon as they start doing this, they've changed where the bottom of it is, and you can see it's like a little convection current tank. Isn't it beautiful? And but that'll make them mad. And the other things you see, always have an extra jug for yellow, because that mixes the quickest.
Oh, yes,
And I say, hopefully I did this time too, I will say I need these 4 distinct colors.
Right.
Because what they'll do, they'll start doing stuff like this, and
And it's already
wait,
just 2 of, just 2 trials there is already.
oh, got it. Well, they've changed the density of the yellow. They've already changed the density of yellow. And so all of a sudden you'll have colors that aren't the right colors because they've mixed them all up. And so that is not the red we started with. And so at that point I'll stop and I'll be like, all right, Sarah, I would like you guys to hold up red, please. And you roll that up. I'm like, that is not red. That is some kind of ugly color, but it's not the red I gave you, the beautiful red. Dump it out, rinse it, and refill it.
Okay.
And I tell them, you can only do that once. Why is her red not red anymore? Oh, it's been contaminated. So we talk about contamination and being careful not to contaminate. Now, at the middle school level, and if grade school teachers do it in grade school class, they're still going to do some contamination. That's why I let them contaminate it first so they see what they've done, and then we stop and they have to refill it because you don't want to take your time to go around refilling it each time. And so have them refill it. So that's the introduction of it.
Okay.
Okay, Sarah.
Okay.
This is actually one of my favorite lessons to teach.
Okay.
I have, when I first came to Purdue 20 years ago, someone had just given us a copy of a density lesson.
Yeah.
And so we got this. I don't know where he got it. I don't know if he found it somewhere, or if he made it. I have no idea. And so I don't know where it originated with, but I know I've been doing it in literally hundreds of classrooms in the last 20 years.
Okay.
And it's one of my favorite activities to do. Oh, I need a whiteboard. Do we have a whiteboard in here? We'll figure it out. We'll figure out when we get to it.
Okay.
There's things I can draw on, but because there's one thing we got to do. I stole from a teacher like 15 years ago, and I've been doing it ever since.
Okay.
And so, but enough to it. All right. I will. We're recording this now, but after we're done and we have everything together, I'm going to record the introduction I do to my students, and I'm going to cut that and put it in front of how we actually do this. And so that way we have the stuff, and I don't have to make it twice.
Makes sense.
Okay. But for the density straws, hopefully if I've cut things right, you've already seen the introduction, and now we're talking about the setup, how we set it up. Now, I'm a simple person, extremely simple. And so, but I will tell you, on the days you're setting it up, sure doesn't hurt to have your lab coat on.
This is very important. I've also taught this, and you just can't ever have enough lab coats.
Yes. So,
Mr. Smith. I like it. No one's gonna take it away from you.
That's right. Back from my classroom days. And so, I've ruined a few shirts. And so I keep this basically for this lab.
Mm-hmm.
And usually I wear my gloves, but they're the whole COVID thing. We,
Sure.
got rid of all of our
No,
stuff.
we don't have them.
And so, all right. So I mix this up very simply.
Okay.
I do things as simple as possible. I'm just kind of, it makes sense.
Mhm.
And so what would I do? I used to use gallon jugs. Quite simple. I use gallon jugs.
Right.
You'll need 4 gallon jugs for the activity.
Okay.
Now I recommend, and you'll see in the PowerPoint thing, I recommend having at least 12. You need 4 for that activity, but if you're going class after class, you kind of need 2 sets for a class to
And
set
why?
it up.
Why do you need 2 sets per class?
Well, per class because you're going through that much.
Uh-huh.
But it's so, and then that gives you time when they're working on it to make the next set for the next class.
Okay.
But then what you're jumping to is why you have to change in the middle of the day.
Uh-huh.
You tell the kids they go through the lab, they do it. They're frustrated, they have fun, they enjoyed it. It was a challenge. They're excited. They tell their friends, and they tell their friends the combination. And so we change the combination in the middle of the day because, well, we learn. We're smarter than they think. And so, and that's hilarious because then after lunch, you'll have some kid come in and just determine, because he knows the combination.
Right.
He knows the order, and he will sit there for over half the, he'll be the last kid done. Because he knows it's the order because his friends told him how to do it. And so he'll focus all of his time on trying to get that to work, and it's not working, and he'll be frustrated. I'll be laughing because how I know.
That's evil.
I know. All right, so what do we need? We need 4 jugs. I fill these half with water just to save myself some time.
Okay.
And I always fill them half with water though before I put the salt in it. Because what I've found, it's a whole lot easier to mix up.
Oh.
If you dump the salt and the food coloring in, then start putting water, it tends to be crustier and harder to shake up.
Yeah.
And so I use, not well, you can see, a scoop. All right, here's the easy combination. You'll remember this. You'll remember this because it'll be really easy. All right, we put 0 scoops. Oh, this is a 1/4 cup scoop, a 1/4 cup soup,
1/4
and
cup.
it's just regular salt. Salt doesn't have to be kosher. Doesn't have to be just salt. You know, the cheap stuff. And so 0, 1, 2, 3
Okay.
on the scoops.
There's our 1. There's 2.
And so this way it's foolproof. I won't say foolproof because every once in a while I forget how many scoops I put in because I'm talking while I do it to other teachers. All right, and so boom, there's our salt. But now we need the coloring, right? And I don't know what I did with lids. Now, all right, so for food coloring, what I have hiding back here are my little containers because it's when I do it all day, I like to be prepped and ready. What I do, I don't know if I'm allowed to say company names. I go to GFS and I get the big bottles of food coloring.
Okay.
And then a few years back, one of the labs I cleaned out and they had these little vials.
Oh, perfect. Yeah.
And so I just fill up these vials. That way I'm very consistent what I do. And I just dump one in one of them. Then I'll fill that up later. Or I have a student help fill it up later. You'll know who filled it up. Switch those 2 real fast. Yeah, I told her to switch these 2 because this is yellow. Never put yellow on top or bottom.
Oh.
And don't do what I just did. Never go in the order of the rainbow. And I say that because during our wrap-up discussion, trying to figure out, what caused this and stuff. One time I had a gal, when I explained it was salt, well, it was the order of the rainbow. And so she proclaims, "Oh my God, salt causes rainbows." And so I did an awesome job at starting a misconception for a young lady once. So I tried never go to the order of the rainbow. I try never to put yellow on top or bottom because it's the lightest color. And if with it being the lightest color, kids think it's about color at that point. And another thing that I've not done because I'm a really bad example is I did not pre-moisten my sponges.
No.
There is nothing as hydrophobic as a dry sponge. And so
That's true.
I put I put a sponge. I moisten them generally at each table, so that way we're not using wasting a bunch of paper towels. There's no reason we just can't just keep using sponges. But we're going to top these off. See who can do this without making a mess. And that way we have a full gallon. And so that makes it super duper easy and consistent. That way, if you don't have enough of one, and like in a class, you have to use half this gallon, or you're using 2 gallons in a class, then the colors are consistent. Because you want consistent colors when you're doing it. You really do. There we go. So, give that a couple of good turns. A couple of good turns. More than a couple, I guess, because it had salt in it. This one didn't, so I didn't really care about it. You'll have to give out in a few extra. It has the most salt. So, then every group here, here, that's the good sponge. I gave you the good sponge. You can dry off with it. I will tell you, if you don't get them mixed up right, it'll change the density of the solution. So you really got to get them mixed up well. We'll find out how well we did here in a minute. So there we go. We have a mess. Dry sponges that aren't helping. I mix these up in the back room. And here's each group gets a dump cup, and I put 1 straw per student in there. And it's important to have. And I always make them work in groups on this one. This is kind of one of those things you always do as a group, but for a number of reasons. One, I want them to have extra straws. I want them to have several straws because they're going to think of different ways of doing things. And they'll use 2 straws, and they'll be doing the whole trying to get one in it and trying to pour it down the next. And I tell you, the stuff you wouldn't think they could succeed at, I've seen them do.
Right.
I've seen them like pipette into one.
Yeah, I've also experienced that.
And I didn't think it'd be possible because I can't. I wasn't successful, but those little kids would be successful. Now, so that's the setup. Each group, this is the setup they get. And so between classes, you don't have time to pass it out and stuff unless you have like a break between classes. And so between classes, what I do when the first class, they're setting up here at the counter. All the reds are here, yellows, greens, blah blah, and then the extras of each is setting back there. And then what I'll do is tell each group, all right, this is what you need. You need 1 of each color and a dump cup with straws. Boom. And then I'll throw sponges at them so they all have a sponge to clean up their mess. I remind them if their mess is their mess, it's not my mess, and I'm not your mama. And that pretty much goes for every single person in the entire world because
No one's mama.
no one's mama.
Yeah, right.
So it works for me. It won't work for you with if you
It's
kids.
true. Yeah.
Sorry. But that's your problem.
Yeah.
If you have your child, then I'm sorry. But so with this, I don't tell kids how to do it. I'll explain. I guess I'll go into that now. The easiest way I've found is to go slow. The kids want to go really fast when they do this, and I will go through and I will be like, you need to slow down and just kind of enjoy life. And when you see that nice color there, right? And so I will let the kids go.
Oh, nice.
See it? That's just beautiful. Get that last drop in. What'll happen is, I'll show you things that happen after I show you how beautiful it is. There we go. There we go.
Yeah.
You see that?
Nice.
It's the white. Very nice. Very nice. I warn the kids ahead of time we're doing this, and to not wear their good clothes or to have a shirt or something to put on it. I make sure I mix up in the back room so there's no salt on the table, like we have salt all over the table right now. And I never set them in the correct order. I always mix them up in a random order. Now students, after you say go, and they just stare at it, and others will start playing. And it's your students who don't typically achieve quite as well that get done the quickest.
Yes.
And so I've had, I tell you what, in like a minute, I've had kiddos walk up and, hey, Smith, I'm like, oh, I hate you. I don't tell the kids I hate them, whether you do or not. I don't hate kids, but that's where you have your backup plan. Okay, they kind of figured it out, right?
Yeah.
But did they understand it? And so, and to slow down my ones that figured it out, first of all, if I have to sign off on it in your lab journal, that you have written down the correct order.
That's a good point.
Once again, I'm all about writing.
Science journal.
I know you call it a notebook or whatever.
Science notebook,
you've griped at me before because I think I don't know. I think you always use notebook where I keep saying journal. And I don't know what the difference is.
I don't think there's a difference.
Okay, is that like soda and pop?
Yeah.
Okay.
It's one of those things.
I'm sure someone will leave a comment and correct us, but get a life. But, did I say that? Yeah, I did. And the kids will come up. Eventually, they're going to get it right, and they have to have my initials beside it for it to be approved. Because your next challenge is to show me the next order that works.
I like that.
So show me. Okay. Great. You got one of the orders. Now show me the next order that works. And well, they'll be depressed. And they'll go back and they will work on this and work on this and work on this until we get to an argumentation point.
Okay.
And I enjoy using friendly argumentation in the classroom because once you can justify the statements you're making, so evidence and claims, right? I'll be like, well, how do you know that you can't do it? Well, of course, you'll have some kids say, oh, you can't do this, it can't be done. And those are ones that give up, and it's unless we get them motivated, they're going to give up on everything. And so we assure them that you can do this, you keep going. Then when we ask them to do it 2 ways, do it a second way. And I've done this with adults. If you walk in as the authority figure, like we are in the classroom, even with adults, they kind of look at me like they second guess themselves.
Yeah.
They're like, oh, and they'll walk away. And to start figuring out that second order, and they'll be working at it, and you'll see them kind of look at you like, and they'll just keep working at it. And finally, the kids adults like someone's going to say, you can't do it. You can't do a second order. And I'm like, where's your proof? And so I'll make them write down the combinations they tried.
Okay.
I'm like, if you don't write down what you tried, then you're doomed for a lifetime of repeating failures.
Yes.
And it's okay to retest things, but once you get to the point you're repeating failures, you're never going to find a correct solution if there is one. And so they will go through and make a pattern and figure out, they're like, oh no, we've really tried. Blue has to be on top. If you don't put blue on top every single time, blue mixes.
Oh.
You're right. And so we'll pull a class together. We're like, all right, someone's arguing, questioning me, of all people. Hello, you don't question me. And so we will start an argument, and more or less with them. And so then grab me, there's a marker there.
Okay.
Grab me just a paper towel or something.
Okay.
That's a perfect whiteboard. Or a box lid. A box lid.
Box
That would be a
lid.
good whiteboard. That would probably be better. And so we will get to the point where, okay, they realize there is just one way. It just goes up. Like, well, why? What do you think is going on? 'Cause I don't tell them this is about density. I never tell them that ahead of time. I don't tell them it's about density. I don't tell them what these are. I'm just like, they are unknown solutions. There are unknown solutions. Oh, remind me to tell the good story about the kid going to the hospital. But it's so finally we'll get to, and if someone says density or not, we'll get to the point that it's just heavier. It's heavier. I'm like, it's heavier for its size or for the amount. I'm like, this lab is actually about my all-time favorite thing. It's about density. And density equals, are you ready? Love.
No.
And a kid will always say no.
Oh, yeah.
And they just break my heart. Just breaks my heart.
I see what you're doing.
Then
I
I'll
like
walk
this.
over
Right.
to the other part of the board and I'll be like, density.
Oh.
and I'll
how
stare at them.
creative.
I'll just stare at them until I get the, oh, I get it. And then a couple kids I have to explain to the rest of them because they didn't all get it. And what's awesome about this though, I have teachers telling me that they're like, you did that in my lab. On my final exam, I have kids putting a little heart down there, and it really, it's a visual.
It is.
It's a way to help them remember the formula for density equals mass over volume. And so that's awesome. We talked about
That's
mass and
great.
volume. I'm like, all right, now you know what density equals mass volume. What's that mean? It's density. All right, so you know the mass, the amount of a substance, right?
Yeah.
And your volume amount is taken up. Okay, so then I start off testing them.
Oh.
And so you got to test, right? We'll do the informal test. And so I'll put these out really full like this. I'm like, all right, this one's full of rocks. These two are two tennis ball containers, same size.
Okay.
You do it with anything. I just like these because they're big and kids can see them in the back. And this one's full of cotton balls. And so, which one's going to have more mass to it? Well, oh, definitely this one, right? A lot more mass. Which one, or what about the volume? Oh, the volume's the same. So this one is heavier for its size, which means it is more dense.
Okay.
All right? Heavier for its size. I'll have them point. Which one do you think is most dense? And so we'll start, and that's a quick assessment for me, right? Heavier for its size, and I'm like, all right, which one's most dense? Boom, put them out. If most of the kids are pointing here, you know, I always usually stop, and I'm like, wait a minute, who pointed at me? You know, fun jokes. So we know this is heavier for its size.
Okay.
Easy to do. We can get cotton balls. All right. Another thing that you might have to look around to find, and you might not find one this big. This is pumice, and this is not. It's not gabbro. It's, I don't remember what it is. I even asked like a rock person. I wrote it down, but I don't remember. I'll have to look at my little cheat sheet because I don't remember. It's definitely metamorphic. Feel that. It's heavy.
Man.
It's heavy.
I have to say, it's really throwing me off that you're
But
just
feel that.
holding this thing around like it's nothing. You're just like, yeah.
But-
it's really pretty.
If we could scale
Not very
these.
dense.
They're going to be exactly the same.
Oh, so mass-wise, they're
Mass is the same, but volume is how much space it takes up. So their mass is the same, but the volume is different. So once again, which one is most dense? And hopefully they point here.
Yeah.
You know, of course, some will point at me because I made the joke last time. But so hopefully they'll point here, and then we're starting to understand. We're starting to get that understanding.
Yeah.
And so then I'll
That's
go.
cool with the rocks. I like the visual.
And I'll tell you, those rocks, I got them at, I don't know if I can say, a local rock company.
Okay.
It's in Lafayette, it's Reed's Rocks, but it's a landscaping place.
Perfect.
They sell rock
Yeah.
stuff for landscaping. I went there, I paid $1 each for them.
What a great
That's all
idea.
they were.
Yeah.
And well, I think that's all someone else would have had to pay. They found out what I was doing, teaching with it and stuff, and they let me have them.
Nice.
And they had that big old pumice.
Yeah.
And you go to the science magazines and order one like a half that size, and you're paying like, I don't know, $20 or something like that.
And it looked like there was a part out of there. Had you filed down some of it to make them the same size? Yeah.
In putting them on the scale, the big one was a little bit more. And so yeah, we just.
Just filed away. Some
Yep,
of
yep,
it.
yep.
I like that.
And so my next one, always do that in classroom, so I got to do it now. This is like, you know, scrap wood from my garage. And so they're both spruce. And so same board. This one's a little dirtier, but we're going to pretend it's not. Same board, but they're different sizes, aren't they? And so then my question is, point to the one that's more dense. And now this is where we know if we get how well we understand. And I generally, most of them, it'll be half and half. I mean, and maybe one or two kids will start getting it, and one or two kids will stay. Then I'll be like, all right, so if I take an 8-foot 2x4, and I take a foot of that and saw it off, did I change the material? No. Did I change the size? So this one is 7 times smaller. What about the mass? Oh, it's 7 times smaller. And so it's just a ratio at that point. It's the same material. We didn't change the density of it. The material didn't change. And that's part of our standards, right? Understanding that a pure substance, material doesn't, or it doesn't change, right? And so if this was a nugget of gold this big or a nugget of gold this big, the
Ice
density is the same.
Right. Another thing, ice cubes. You know ice cubes are going to float. Well, is a larger piece of ice going to float less than a smaller piece of ice? I mean, it's the material is still the same. So it's...
There would be. Might have to be a little careful with ice cubes, though, because when we get into buoyancy,
Oh, okay.
because they're going to think, well, half of it sinks.
Oh.
So it's heavy.
Right.
So be careful when we start which things we use as examples, because then we get into the buoyancy and there's more variables.
Okay.
And so it's
Yeah.
there's yes, you're right. With the density being the same, but we got to be careful with that.
Okay.
And if it's dirty ice too, right?
Oh, sure. Yeah.
And so it changes it, just like we put salt in these.
Yeah.
But that's density straws.
Okay.
The other thing, I don't have well, this wouldn't work anyway. It's just so old. I got one of these at a local mart for like $10.
Okay.
I got a lid for it around here somewhere. Actually, I had two of them, but I broke one lid. And I fill this up with water, and I put the whole Diet Coke and regular Coke in there, and the Diet Coke will flow. Oh, by the way, make sure they're both room temperature.
Oh.
That does make a difference. Threw
Okay.
me off once because I didn't realize what the heck was going wrong with my project. It was not working. Like, I've done this tons of times, it's
Right.
not working. And we'll even do like we'll have like science nights, and I will set 2 tanks up exactly the same. That's why I got 2 of them. I better not put them on there, otherwise I'm gonna have one lid. I'll put 2 of them. I'll put the Diet Pop in one and the regular in the other. And I'll be like, what I do to this water that makes that flow?
Oh my gosh.
And the parents are, well, you've added salt to that, or you've added something to that. Or, I'm like, how can we test that? Well, you just got to switch them. And so this one's floating, of course. I'll take them both out, drop it in. I'm like, see, it floats in this one. What did I do with that water? And they're like, I'm like, yeah, this one always floated, this one always, and so yeah, I start trying to confuse them best I can until they realize it's not the water, it's the can. And then we'll talk about, just as we added salt here, there's added, well, not in this one because it's yucky Diet Coke. The good regular Coke has the added sugar. And so, we look at those, how many, what's that in grams? Oh, wait a minute, we massed things out in grams, how exciting. And so that's 35 grams more for the same volume. And so I like doing that. This is really old, and you could feel it's not right.
Oh, yeah.
And so,
You're going to drink that for lunch, right?
I wouldn't drink it if it was new. Yucky. All right, that's density straws. And so, good luck.
Kid in the hospital.
Oh, yeah, I was going to tell this story. I'm sorry for wasting your time. If you don't want to hear a story, just jump ahead in the video, okay? All right, so one of my teachers, because like I said, I've been teaching this for 20 years of professional development, right? And I go to classrooms and teach it too. One of my teachers, she calls me one night, and she's like, oh, Steve, you have to hear this. I'm like, okay, what? And it was a high school, actually, chemistry teacher.
Okay.
And so, and they're like, well, you never drink anything in chemistry because we don't tell them what it is. I said it's an unknown solution, and we would never want to siphon with our mouth because some kids will want to suck it up, right? And so I'm like, oh, we never siphon with our mouth. These are unknown solutions. They're going to
As a chemistry teacher, even that's not going to stop them. So if they want to drink it, they're going to drink it. But
so,
you tell them.
You always have that one that's going to do regardless.
Right.
Well, she tells them these are dangerous chemicals,
sure.
right? She's like, oh, you definitely wouldn't want to drink. Well, one kid does.
Okay.
All right, and so that young man and his buddy's like, hey, he tried it, and she's like, oh my, I hope you're all right. It's just salt water, yeah, but she didn't tell him that, right? Well, it started messing with his head.
Oh no.
And he started feeling sick.
Okay.
He goes home and he's like, stomach's hurting and he's sick, and his parents are like, what happened? He's like, well, I drank something in chemistry today. They take him to the hospital.
Oh,
he's in the ER. The ER calls the principal calls the teacher. What did you have in chemistry class today? One of your students ingested it. She's like, salt water? And I was like, huh? He psyched himself out so much that he thought he was poisoned himself. And
That's a hard lesson to learn.
oh yeah, oh yeah.
That's funny.
It's I still laugh at it, and it's been years. I'm sorry. I know I shouldn't laugh. So that's Density straws.
Yeah.
Good luck. It's a really good one because it drives home the idea of density. Density
Yes.
seems fairly abstract.
Very abstract.
You know, okay, heavy first sight, okay, some things are, but you have them go through this and they will understand that those solutions, they are a density base. Then we explain, oh, we put salt in them.
Mm-hmm.
Oh, and oftentimes I will, well, not oftentimes, every once in a while, I'll be honest, most of the time I don't, simply because I'm always in a hurry, especially if you're doing a 45-minute class, getting through it.
Yeah.
That's an art. It takes time knowing when to push them, so you're not telling them, so they still develop that. And if it's a 45-minute class, it can be hard
a challenge.
to get them through that quickly,
Yeah.
and to know when to stop them and give them to help them,
Yeah.
to give them help. And so, but where was I? What was I telling you?
Just trying to get. Oh, so you don't always. Sometimes you're in a hurry, but you don't.
Sometimes I will make the next classes up in front of the first class.
Oh, okay.
If I have time, well, usually it's like 2 classes ahead because, like I said, I keep 12 of them, and I fill them all up before class, and then I fill up the first set, then I refill that one.
Okay.
Because it takes about a gallon per class, is what I've found.
Yeah.
If you use the bigger cups, you're going to use more, but this works great. But I've even so that make sure they understood, and oftentimes you have usually it's inclusion class. They need that extra scaffolding. And so I will literally make up the next one in front of them so they see exactly what I did. Even though you told them, oh, I just put salt in it, they see exactly how, oh, we're putting more and more and more. And I always, grab that next marker.
Okay.
Grab that marker
Yep.
there. Because I will put on the board as a visual, I will draw the straw, right, at the end. And we will put the lines in it. Will be like, what was ours?
I think it was
remember.
in order: blue,
Blue,
green,
green, yellow, red. Yeah,
green,
because
backwards. Yeah. Think. Oh no, it wasn't. No, never mind. Sorry. Yeah. I'm getting confused because it's the rainbow. Okay.
don't question me,
Okay.
ever,
Okay.
ever. But and like I said, never go in the order of the rainbow. That leads to misconceptions. But it's so I will draw it. We'll talk about. Okay, so this is least dense. This is most dense.
And they should be including a sketch of that in their science journal or
Oh
science
yes,
notebook
definitely.
as
Definitely.